Hey everybody and guten Tag. My name is Stefan and welcome to CNC Kitchen. This is the first video of a series in which I will cover tensile tests of different 3D printing filaments. I built myself a tensile testing machine some months ago and I would like to share the results which I gathered with you. I will post a video about this machine, the specimens I used and how I gathered the data in the future. Disclaimer: the tests are not performed on any officially calibrated test equipment. The procedure and specimens are in the style of DIN EN ISO 527, but are partly altered to fit my equipment. The first filament I'm going to talk about is E3D's or spoolWorks edge material. This material claims to be as tough as ABS, but similarly easy to print as PLA. Edge is a PET or copolyester type material, which was modified to increase its suitability for FDM 3D printing. I purchased my roll of 1.75mm Oxford blue filament when I ordered my V6 upgrade kit for my Mendel 90. The costs are around 43 euros per kilogram, excluding tax. I had high hopes for this material because I had already been using different brands of PETG on my old printer, but never really got the results I hoped for. I had been printing this material on my original Prusa i3 Mark II at 240 degrees, 0.2mm layers and 50% cooling fan at first, but had huge problems with stringing. Playing around with the retraction settings and extrusion multiplier did not help a lot, but decreasing the temperature to 230 degrees made it a little bit better. Bed adhesion was great. Actually, I started printing all of my parts on blue tape because I was afraid of damaging my PEI build platform. I didn't notice any smell nor warping, which distinguishes it from ABS and makes it usable even in homes. Coming from PLA, it might be necessary to adjust your extrusion multiplier. Due to the softer material, the hopped bolt engages the filament at a lower diameter, so I ended up increasing my multiplier by 5%. Now to the tensile test results. I printed 3 lying specimens and 2 specimens in the upright position, which I will use to test the layer adhesion. The lying specimens showed good strength with a maximum tensile strength of around 50 megapascals or 7.3 ksi. The specimens did not break during the test. They were so ductile that I had to cancel the test after a while. Strains over 100% can be handled by this material without any problem. Still, if you stress the material over and over, it will break due to fatigue. Additionally, loading it faster will also not give you the high breaking strains, which I got during my slow test. The Young's modulus was around 1700 megapascals or 250 ksi, which makes it around half as stiff as normal PLA filament. The 2 upright specimens failed much earlier without any necking in between the layers at around 7 megapascals or 2.5 ksi. This is only a third of the strength of the lying specimens, which suggests that the layer adhesion is not the best. I noticed during my test that the layer adhesion increases by some amount if you use higher temperatures and turn the part cooling fan off. Since this degenerates the printing quality, it's not a realistic scenario in my opinion. In conclusion, I think the results are quite similar to other brands of PETG material. The great bed adhesion might be something which you might really benefit from because less prints might fail. Axial strength was good, layer adhesion only okay. The print quality is unfortunately still far away from PLA due to artifacts and stringing. Since this is the first video in this series and my second YouTube video so far, I would really be happy if you leave some suggestions down in the comments. Let me know which materials you want to see in future videos. I'm actually planning to set up an online database where I can gather all the material tests I've performed, but this might still take a while. If you would like to know how your printer with your favorite material performs, just write me a message and we can figure something out. Thanks for watching. If you like this video, give it a thumbs up. If you want to see more of these videos, consider subscribing. Have a great day and I will see you next time.